SwayamPrabha. Digital India. Educated India.
Hello everyone. So, we will continue with the module which we are discussing the textiles for protection from air pollution using the filter fabrics. So, that is our topic of discussion here. Now, textile air filter, let us see the overview of this first. So, textile air filters are there actually effectively they are reduce the air pollution by capturing the different size of particles, coarse particles and fine particulate matters like PM 2.5, PM 10, and how do you do this? By designing the specialized fabric structures. So, by structural modification we can control the emission, we can restrict the, we can capture this power, this type of fiber by specialized fabric structure means by adjusting the diameter, by selecting proper diameter, by controlling the pores, and by through all this we can capture all these particles from the polluted air. And this type of textile filter, air filters are used in wide areas. In the as a mask we used to capture the fine particles, even bacteria, virus, that type of fine particles, ultra fine particles in the nano level, that we can capture. Industrial bag houses, that it combination of very coarse particles to fine particles, and in home application, that is a home air purifier we can use. And here in this thing, in this type of applications, we use typically different types of non-woven structure, needle punch, and melt blown is nowadays widely used, melt blown polypropylene, and also that is high efficiency particulate air filter, that is HEPA filter grade, where we try to get the very clean air. So, HEPA filters are used basically for the clean room application, even for the automotive filter, their HEPA filters can be used. So, the air pollution is basically, it contains of particulate matters in the air, which is called PM, particulate matter, volatile organic compounds, VOCs, even gases from the industry, different types of gases are used from industry, vehicle or urban sources, different types of urban activities like construction activities are there. So, different types of production activities like burning fuel or different types of activities, it is generated from vehicle, this type of particles generate, and PM 2.5 and PM 10, which we have, as we have mentioned, which penetrates to the lungs, causing respiratory issues and cardiovascular diseases. So, this PM 2.5 and PM 10, it is very dangerous for our human health. So, we should actually arrest all these particles, and the textile material textile filter is a very easy solution through which we can arrest all these particles. So, you can see the globally 7 million deaths occur annually, which are linked to the poor air quality. So, due to the air pollution, the lifespan also reduces, and large number of deaths are related to this type of air pollution related to the poor air quality. We have to actually either reduce this air pollution from the source, and in some cases from the source it is not possible, then we have to protect ourselves by using different types of filter. Even in the source also we should use the filter medium, and textile filter is the easiest one which can be used easily. The health impacts: the fine particles evade the natural defense. So, whatever in our nose, whatever natural defense is there, that physiological or natural defense, fine particle actually penetrates through this natural defense, natural defenses, and entering our blood streams, okay, and which actually generates the asthma or chronic obstructive pulmonary disease, COPD. This pulmonary disease actually is created by the very fine particle, and also the risk of cancer increases due to the fine particles which penetrates in our body. So, the main affected zone is that is groups of people are the children, the elderly person, and urban dwellers. They are the main vulnerable children, that is elderly person, they have lower immunity like children also, and also in the urban dweller, those people who are at the urban places, there the chances of this pollutant generation is high, because there are different types of activities, industrial activities, vehicular activities. So, different types of activities are there, the concentration density of vehicles are there. So, that type of, that is why in urban area the problem health issues due to the air pollution is severe, and in urban area the plantation is also lower than the rural area. So, textile filters block at the source. So, either you can block the pollutants at the source like bag house, which actually arrest the particles from the cement industry or maybe from the power plant, and at the source either you can filter. If not, if it comes to the air as a pollutant like PM 2.5, PM 10, then at the personal level we can do. Personal level means we can use the filter in the car, we can use the filter in the air purifier in the at home, or even at the extreme case, even after all these things, if it is not possible, then we can use the face mask. So, we will discuss detailed all this ways of restricting the pollution and protecting our health by using the filter fabric. Why are textile air filters? why do you need this textile air filters? We can use other type of air filter. So, the textile air filters are used, basically it is a porous system. So, porous structure is used because it through which the air can pass through, and it helps in trapping the pollutant via different mechanisms, like mechanical mechanisms are interception, diffusion, okay, that this, or there are different other mechanisms are there, inertial impaction, and also electrostatic forces are also there. So, different types of electrostatic we can use the electrate filter. So, you can charge the filter fabric which will attract the particle. So, electrostatic force we can use. So, different principles that we will discuss in detail. Unlike rigid filter main problem is that where the dust cake formation is not there, and which you cannot form the that shape, different shape. So, in textile filter the main advantage is that you can actually, it is a flexible, you can make you can pleat it, you can make it cylindrical. So, at different shape you can get it can get adjusted, and also in textile filter main advantage is that it can form the dust cake. So, for flat filtration, some metal, suppose a metal mesh is there, let us take example of metal mesh. I am drawing on metal mesh, this is a metal mesh, and this is the front side, it is a side view. Now, in metal mesh it actually, due to its stable structure, pore structure, the smaller particle will pass through and larger particle will get arrested, but this particle will keep on removing and falling down. It will not form any cake, but in case of textile filter, so this is the textile filter media. The very small particle initially will be passing through that, but it will, the relatively large particle will be settled on the surface. Then at the, when it is settled on the surface, the pore size of this particle becoming smaller, because it is a layer it is forming, and the gradually the pore size of this part between the particles are smaller than the base fabric. So, after certain time when the this cake is formed, this cake will act as the additional filter layer, and this cake will start filtering out, arresting the smaller particle also. So, if you see after certain time this total system will act as a porous medium and clean air will start coming. So, sometime pre-dust caked, preformed dust cake is also used. Initially dust cake formation is the initial time for some say 1 hour or maybe 1 day depending on the dust load. So, initial cake formation will start, and that will generate that will actually develop one porous additional filter media and which enhances the efficiency over time. This is actually for air filter, this system is there for bag house where high dust concentration is there, and also for water filtration like a geotextile, this type of dust cake, the cake formation, it is not dust cake, that soil cake formation is there and it forms the filtration layer, additional filtration layer which will restrict the soil erosion after time. Stable formation, porous medium is generated which will actually reduce the soil piping, soil actually loss, and its capture rate is actually exceeds 99% for fine dust. Fine dust, very fine dust, more than 90% filtration efficiency which textile filter can provide without sacrificing the pressure drop too much. So, the filter mechanism is the dust laden air pass through the fabric, particles adhere to the filter or cake layer as I have discussed. So, this is the filter medium and the dust particles, different types of dust particles are coming. So, they are captured at the surface or inside the structure, or sometime when the cake formation is there and they are deposited on the cake also. And clean air without any dust that comes out from the through the fabric. So, the dust is collected, solid particles are collected and clean air is passing through. That is basically filtration which we want, and filtration is not the sieving. Sieving is basically we are restricting the larger particle. Okay. So, in sieving process is that one medium is there with a defined pore size, and particles of different size are there, and here the particles smaller than this pore size will get through the medium and the larger particle will be separated. This process typically called sieving process, and filtration is different. In filtration we cannot allow the smaller particle even. Ideally all the particles are to be restricted, but not by reducing the pore size. We cannot reduce the pore size too much, so that it will increase the pressure drop, that we cannot have. So, this particles are generated, deposited, it formed cake. So, it is becoming very thick with the time. So, and we are in a filtration efficiency is increasing with the time. Filtration efficiency is increasing with the time. Now, what about the say in other axis, this is axis y 1 axis and y 2 axis, but with the time the as the layer of the cake or particle deposited on the surface increasing the thickness, the pressure drop will also increase, which we do not want. We want the nominal filtration efficiency, the required filtration efficiency at the rate at the time the pressure drop should not be that high. So, the pattern should be like this, it should not increase too much. So, gradually pressure drop is increasing. So, when the pressure drop is increasing to a certain level, we must clean all this additionally deposited surface particles. So, that is done by pulse jet cleaning, which dislodge the cake without stopping the flow. So, pulse jet cleaning is done, that means intermittent air is flown here at very high speed, which gives shaking activity, okay. And then these particles will get dislodged and the filter becoming relatively cleaner and pressure drop reduces. And with the time it will happen like this, gradually pressure drop will increase because of the some continuous permanent particles are there, and in the surface, close to surface, there will be some particle embedded on the structure. And to avoid all this, to actually remove all those fibers particles, we can have reverse airflow also. After certain time, the reverse airflow to move all these particles. So, what is filtration then? Filtration is a process of separating one substance from the other substance. This substance, the one substance will be the solid particle or maybe any other particle, and next substance will be a fluid, that may be liquid or maybe air or gas. So, that is the removal from one of one substance from other, separating one substance from other substance is the overall concept of filtration. So, the definition is, it is a process of separating dispersed particle from a dispersing fluid by means of porous medium, that is the filtration. We have dispersed particle, like in air the particulate matters are there, and we are using one porous medium. This is the porous medium. Why do we want porous medium here? We can have one non-porous medium to block these particles, but which is not the case, because we have to clean this air, and to clean the air we have to flow this air through a medium, and air can be flown through the porous medium only. So, we are flowing this air and the particles are getting separated, air is flowing. So, the idea of filtration is not to stop the fluid to flow. Fluid should flow, maybe water, maybe air, but at the same time it should arrest the dispersed particles, solid particles. Okay. The dispersing medium can be gases or mixture or a liquid, air, gas, anything. any gas or mixture of gases. Now, if you see this system here, this is the upstream side through which the from which the pollutant coming, and dispersing fluid may be liquid, may be gas, air. At present we can assume it as air. So, in upstream side the pollutants are there, and this is the face side of the filter media. This is a filter media. In our case it is a textile fiber, textile fabric. So, filter fabric is there. This is filter fabric, and here you can have thickness, we can control this thickness, dispersed particle is there, and dispersing fluid. Dispersed particle is the particles in the air, and dispersing fluid is in this case it is air is the dispersing fluid, and while it is passing through the fabric, through the thickness the air is passing, the particles, some of the smaller particles penetrate inside the structure, and it gets trapped within the structure by different mechanisms that we will discuss, and in the downstream side the clean air is moving and particles are deposited inside the filter. That is a depth filtration took place, and also at the surface face side there is a deposition of the filter cake, formation of filter cake, which I have already explained, which enhance the filtration efficiency. Now, why non-oven is basically used, preferred, although oven fabrics are also used. Non-ovens main advantage is that it saves energy. For same filtration efficiency, for the same fine particle size, the non-oven if we use, it will actually have lower pressure drop, means it will reduce the energy cost. But equivalent, for equivalent particle, if we try to use the oven fabric to get the same filtration efficiency, we have to make the fabric very compact. Like for PM 2.5, basically for PM 2.5, if we want to arrest the 2.5 micron particles, in that case we have to have one fabric which is very compact structure we have to generate. So, that is actually that will enhance the energy cost. So, non-oven you can have at higher production rate, higher than other type of material. So, cost of production is low, and versatility, we can use wide range of fibers without any difficulty. We can produce non-oven filter. So, we can use for high like high temperature filter, we can use for water filtration, for any other filtration. So, non-oven fabric is used. We can recycle easily because it is directly from the fiber we produce. In oven fabric, recycling is little bit difficult because of the yarn formation. So, yarn you have to get the fiber from the yarn is you have to use other Hart's method which will damage the fiber. So, non-oven recycling is easier. So, there are different types of application area. So, air filtration we can use a liquid filtration, nonwoven can be used. The filters like engine filter include both air and liquid filtration. So, engine filtration where the concentrate that air can get that water formation is there due to the cooling, the condensation is there. So, that air that water liquid formation is there. So, in engine filtration both air and liquid filtration is used. So, here at present we will be discussing only the air filtration. So, what are the textile materials we use? Basically the fibers which we polyester is widely used for durable and cost effective, and its melting point is also high. For industrial use we can use polyester. PTFE we can use for chemical resistant, for hydrophobic application we can use PTFE coated. Gore-Tex is one commercial product. Polypropylene is very widely used for lightweight and commonly used for face mask. And nanofibers are also used for very fine particle, ultra fine for submicron particle capture due to its high surface area. Now, if you see the comparative analysis of this 4 different types of materials, like polypropylene, polyester is its high durability, its advantage is it is durable and it is used for PM10 for 99% efficiency is used, and it is mainly used for bag house. In bag house sometime it is a hot air damages the polypropylene. So, in bag house we use typically for high temperature. So, polyester is used. So, polypropylene and it is polyester is also relatively cost effective. So, polypropylene it is due to its lower density, it is a lighter weight, and PM 2.5 we can use 95% efficiency, or also we can, if by combination we can enhance this efficiency as we different type of layer like spun bonded, melt blown, spun bonded, this type of multiple layer we can enhance the filtration efficiency, and is widely used in face mask due to the it is hydrophobic in nature and it wicks the sweat quickly. So, wicking character due to its high wicking characteristics, and it does not absorb the liquid. So, it our skin remains dry. So, that will use the comfort, that will enhance the comfort characteristics. So, polypropylene used for widely for our face mask, and PTFE it is corrosion proof, and harsh industrial environment we can use more than 99.9% filtration is there. So, in case of industrial, the harsh industrial requirement we can use, and nanofibers are used basically in HEPA filter. So, more than 99.5% the filtration efficiency we can get. So, with the submicron pores are generated which arrest the very fine particles like virus or bacteria, this type of particles we that this nanofibers arrest. So, personal protective masks are the example of air filters. You can see the construction of mask, that we will discuss in detail the different construction of mask. So, in for nanoven we use this for this mask we use the nanoven, different types of nanoven like spun bonded, melt blown, spun bonded, it is called SMS structure that we have discussed. The spun bonded in both the sides enhance the mechanical strength, and melt blown enhance the filtration efficiency. So, multi-layer structures. So, this is the spun bonded, this is the melt blown, and again spun bonded. So, this type of structures are generated, and where commonly used mask like N95, KN95, this mask for this mask. So, filtration efficiency is more than 95% for 0.3 micron particle. So, N95 stands for 95%, more than 95% filtration efficiency we get for 0.3 micron particle, that is the N95 definition here. Now, you can see the construction of the face mask. You can see the polypropylene spun bonded nanoven fabric. This is S, spun bonded nanoven polypropylene, and which is used to effectively block the visible objects such as droplets, the outer side. This is the outer side. So, this is polypropylene spun bonded fabrics are used. These are the droplets and visibly objects particles, and the smaller particles penetrates through this, that is created because to reduce the pressure drop. So, smaller particles penetrate, but it is restricted from further penetration by melt blown, which is finer pores. These particles are restricted. So, filter non-oily particles here, and the third one is again polypropylene nanoven spun bonded fabric. This absorbed hot air inhalation. So, exhalation. So, it absorbs hot air exhalation, hot air from our breathing. During exhalation we exhale the hot air from the body and leave the skin dry and comfortable, because this layer, it is basically made of polypropylene. Polypropylene is not does not absorb water, so it becomes dry, but due to its high wicking characteristics, whatever the moisture generates, it goes to the next layer. So, that is getting our skin becomes dry, and the particles are arrested at the majority of fine particles are arrested at the middle layer, which is melt blown. So, we are protected from the particles, particularly for less than equal to 3 micron particle. So, that type of around 3 micron particle if we use the N95, but for fine particles we have to modify this structure. So, superior to cloth alone, sometime in earlier days or also nowadays we try to use the cloth, okay, single layer cloth, but here it is superior and which offers only 10 to 50% reduction. Okay. Ideal for urban smog. So, the cloth efficiency is typically 10 to 50%, that varies depending on the pore size. And for urban smogs, this type of this personal protective mask is important. Industrial bag house, another application for textile filter. So, it may be vertical or horizontal. Here the example is given a vertical orientation, it can also be horizontal orientation. The fabric bags are there, large number of bags. If we see the construction of this bag house sometime, as I have already mentioned, its dimension is maybe sometime more than the actual industrial activity, production activity. This is mandatory just to arrest the particulate matter. So, industrial bag, filter bag, that in the housing process, high volume of flue gases from cement and steel plants or maybe power plants. So, this type of high volume gases are coming. Here the system, if we see here, there is a poppet valve, a pneumatic valve mechanism used to control the airflow during cleaning cycle, particularly to isolate the filter chamber or manage the reverse air cleaning. Now, the normal system, here the air, compressed air is there. Now, I will show you that. Now, here you can see the dusty air is coming, dusty air is coming from the this side, this is a dust air, air intake is coming from the plant, okay, along with the particles. Now, the bags, large size bags are there, it is with the frames are there, on the frame these bags are hanged, the height may be very high, and on the frame, metallic frame, the textile bag filters are arranged. Now, here the dusty air is coming and the which is actually penetrating through the bags from the surface, outer surface, and the dust particles are arrested at the surface. Okay. Typically, these are actually surface filtration, and the clean air is inside and which escape from the middle point. So, here the clean air is escaping, okay, and so and it is going out, air outlet. So, dusty air is coming from the side or surface and clean air is exiting from the center of the cylinder through the cylinder cross section here, and its clean air. So, the production process is actually even in textile industry, like in blow room, this type of bag house is required. So, here the dusty air is coming and the clean air is coming to the environment. It is, or maybe it is taken into the plant itself. So, that type of circulation will be there, and during the process this bag will be loaded with the particles, small particles on the surface. It will be gradually fully loaded. So, this loading will enhance the power cost, because it will to allow the dusty air to pass through a certain at a certain rate of air flow, this particles, the cake formation will restrict the motion. So, that pressure drop will increase, which will enhance the power consumption. So, to reduce these things, this buffet valve is used, which is a pneumatic mechanism is used to control air flow during the. So, here the reverse air flow is there. One compressed air flow will come from the reverse air flow to actually dislodge the particles on the surface of the bag house. So, individual bags are there, and bag house is made of the large number of bags. So, in all the bags the compressed air is blown, which will shake the bag, and the particles will dislodge and will be collected at the centrally. And also there will be pulse jet air which is being, which will strike on the bags from the outside, again that will help in shaking the mechanically dislodging the particles. Okay. So, this is the principle of bag houses, which is used where air filters are used. So, reverse air or pulse jet designed to minimize the downtime. One thing we can do also, we can remove the filter from the bag and we can clean the bags and again reinstall. That will actually take time, and we have to stop the plant and frequently. So, to avoid these things, these arrangements are used, reverse air flow and pulse jet, and we can change the bag or replace the bag after a long time. So, because when the dust load is very high, the dust cake formation will be very quick, and in that case we cannot frequently change the bags. So, pulse jet and reverse air flow is designed. It reduces the emission, okay, to a lower amount. Next example of air filtration is that home air purifier, which is very commonly used nowadays in different offices or residential area. In residence, at home we use, particularly in the urban area where the air pollution is very high. So, this is the construction of the air purifier. Where we can see this is the first is the pre-filter, coarse filters. So, the open structure textile material is there, and then next layer will be HEPA filter. So, high efficiency particulate air filter. So, here we can use the HEPA filter. So, coarse filter to prevent, to arrest the coarse particles, the larger particles, and then HEPA filter to prevent the fine particles. So, these two layers we use. Along with that, there is a activated charcoal filter is there, relatively open structure. The main function of activated charcoal is that to absorb the odor, so any volatile material or any odor in the air, that will absorb, and to make the air clean, and also the any odor film, suppose some outside some bad odor is there. So, that will try to absorb by this activated charcoal filter. So, these cartridges are there and they capture the allergens and pollutants, and portable units used for use a pre-filter extended time life. So, this with pre-filter is used, effective for indoor particulate matter from cooking or traffic. So, like for in the this type of filter is used in automotive, so, or maybe in from traffic or maybe from cooking, whatever particulate matter comes into the house, for that type of air this is very effective, this type of filters. Now, coming to the automotive cabin filter, again multi-layer filtration is used. Now, you can see in automotive air filter, first layer is non-oven. So, outside there are different types of pollutants are there. So, activated carbon textile blocks the gases analogs to particulate alongside the particulate. So, this along with the particulates, this activated carbon filter blocks the gases, it absorbs the gases. So, you can see different types of pollutants are there which is coming to the automotive cabin, and first the non-oven fabric blocks the, it is a pre-filter which blocks the large particles, and then activated carbon absorbs the gases, and fiber sponge is also used, that is the non-oven fabric is used, again activated carbon and then non-oven. So, non-oven fabric. So, different layers are used depending on our air quality, we can select different types of air filter for the automotive cabin. So, commonly HVAC filter, heating, ventilation and air conditioning filter system is adopted. So, improving the driver safety in the pollution side. So, polluted, in the case of polluted, when the any vehicle is moving through the polluted area, cities, in that case the passengers and drivers should be protected from this pollution. Now, let us see the performance matrix of this type of filters. Efficiency, 99% efficiency, more than 95% for PM 1 micron, PM for particulate matter more than 1 micron, we get 99% efficiency. We can see that due to this multiple layer for PM 2.5, 80 to 90%, allow the speed, basically it will be PM 10, basically 10 micron, and it allows the airflow 1 to 2 meter per minute, and lifespan is 1 to 3 years. So, this automotive air filter, so these are the standard requirement performance matrix, and we can test it by ASTM or European standard EN 1822. So, that we have to test. Now, try to see the comparison with the other type of alternatives. So, textile filter we can get efficiency of more than 99%. So, we can get, and its cost is medium cost, and we can clean it by pulse jet or maybe by shaking, by washing also we can clean it. It is a reusable. Okay. Now, electrostatic filter. So, electrostatic filter, the filtration efficiency is lower than the textile filter, 90%. Cost is high because we have to charge with the electrostatic charging, and for that power is needed. Cyclone filtration, it is a low cost, but efficiency is low, and fine particulate matter it does not actually remove. So, these are the alternative with the textile filter. So, where we can see that textile filter is superior to all this, but electrostatic filter, electrostatic charge we can generate on the textile material to enhance the performance, that is okay. Now, for a case study we can see one for industrial case study, the bag filter in cement industry cuts dust by 99.9%. So, regulation it complies. So, 99.9% dust is actually arrested, only 0.1% dust is going to the environment, which is as per the regulation, and it reduced visible emission and operational cost by 20%. So, visible emission is not there, as if the clean air is coming, and operational cost is reduced by 20%. And case study for personal protection, surgical mask with melt blown layer reduces the particulate by 45 to 54%. Respirator trial up to 95% in the trial. So, one is the melt blown layer is used, where 45 to 54% is particle arrestance, but in respirator if we use 95%, and for that if we use the multi layer, then we can enhance the efficiency. Everyday fabrics underperform. So, if we use the normal fabric, normal woven fabric, that will not be able to perform. So, what are the advantages of textile air filters? Versatile, for variable dust load, we can use wide range of application, different types of dust load we can use. We can have it has lower energy cost as compared to the electrostatic precipitation, ESP, scalable from personal to plant scale. So, we can use those this textile air filter for wide range of applications, for any, maybe for personal protection, from plant protection. Ultimately, if we in the plant scale, if we can use, that will indirectly actually protect our human health. And textile filter, as I have already mentioned, this is recyclable. We can recycle the textile fabric and reuse the waste again. And the challenges with the textile air filter is that blinding from sticky particles, that is problem. So, in a structure, in the structure, suppose any sticky particle comes, which is entering into the structure. If the sticky particles are there, it will actually gradually blind the pores, so that the air flow rate will be reduced. If the sticky particle penetrates inside or maybe at the surface, the removal of these particles, adhered particle, is very difficult. And high initial cost, because we have to actually, if we want to produce a textile filter, so initial cost, we have to we need a plant, bigger plant, and temperature and chemical limits are there. For synthetic fiber, we can use maximum 250 degree Celsius, but there are high temperature resistant fabrics are also there, like meta-aramid, aramid fiber we can use. Moisture sometimes causes you swelling or sticking characteristics. So, these are the different challenges. So, we will stop at this point and we will continue with the air filtration or filtration as in general in the next session. Till then, thank you.